All right. Can everybody hear me? Yes. Perfect. So I think it's the last hour of the day and time to pull out my 100 sliders. Ready? Yes. Also, just kidding. I'll try to finish it as quickly as I can without boring you with the PowerPoint sliders. And having said that, let me present you the topic for me. It's the observability in AWS. And how do we achieve traceability? How do we ship out metrics and logs of the payloads that are deployed in AWS? But before going into that, a little bit about myself. My name is Aritra. I am a senior cloud consultant. Started with Playground last month. Apart from that also, I am a AWS community builder. And you can find out toying with AWS and other tools. If you scan my profile, it contains basically everything from GitHub to LinkedIn and my blogs as well. Moving on to today's table of content, how do I plan to divide my 45 minutes? It will not be PowerPoint presentations. I'll try to switch between the visual code, AWS console, and then I'll leave some time at the end for you to come back to me with any questions about anything. It can be out of this topic as well. So the first topic of the day is what is observability? Coming from the school of IT, where we had a big system, a monolithic systems, where we had the logs containing 100 GB shipped to us, where we had to decompress and check for all the issues that had occurred. Fast forward to now, 5 years down the line, AWS and I know other cloud providers has also come up improving how to see the metrics inside the system. And I guess around 5-6 years ago, this term was coined, observability. And what are the three main signals that are responsible for it? The first that you can see in the slide is metrics, and basically it helps us detect how much compute capacity is inside the system and what sort of trade-offs that we can do while hosting any compute inside it, be it serverless or be it normal one. The second signal is logs, and this is, I know, very much familiar to us. I mean, and it not only helps us to diagnose problem, it also helps us to find out implementation of a function or code snippet that we do. And SaaS systems like Kibana, CloudWatch, Datadog, and many other in the market that basically helps us to understand and dive into this signal. The third one is the traces. And traces, I will particularly focus on this topic because I have a demo that I have scheduled for you to showcase. But normally right now what traces mean on a high level is basically into a multi-system microservices, or let's say when we have a request propagating through multiple systems, we can find out like what sort of a latency that has occurred, if there is any metadata annotated with you, and of course, like similar to the other signals, we can use X-rays, Zipkin, and other systems as well onto this. And whole of these three signals basically consolidates as something called observability. And onto my right side of the screen, you can see a Datadog portal, which has all the signals that are transcribed from a third-party system or from multiple payloads. So you have a single pane of glass, even though I hate this term, single pane of glass, but yes, you basically have a single place where you can see what sort of metrics are coming out, what are the traces, or what sort of a latency that has what sort of a latency that is responsible. And lastly, you can also see like the logs for any particular system to understand the functionality of it. Moving on to just consolidate what are the benefits of this and why should we all do this activity. The first is, as I mentioned, when you understand the latencies of any system, you can basically do the trade-offs of, okay, should we make it as an event-driven one, or should it be just a REST-based HTTP one? Or for example, if you see the metrics, or if you start learning the metrics of a compute capacity, compute system like EC2, or for example Lambda, you can do the trade-offs on that as well, like reduce the memory, reduce the concurrency, just to ensure that you don't over provision or you don't under provision. And what are the three main values that you gain? The first is your system becomes mature. It ships out more telemetric data. You can play around with the cost. And right now with AWS and others promoting their FinOps foundations, and I know FinOps as a separate vertical coming up quite fast. Cost is a very important thing that we have actually seen in customers trying for us to investigate into. And then you can analyze the whole system. You can get a very much greater insights onto those deployed as part of when you use this observability. Now coming to this slide, the reason that I kept this was just to ensure that what is the difference between one of the previously existing term called monitoring, because all of the things that I talked about basically falls under monitoring. So I have been getting questions from different part of this realm that okay, observability is pretty much similar to monitoring. But just to show it on a visual way, so monitoring is just what we see on the tip of the iceberg. And there's a whole lot of systems, whole lot of metrics, whole lot of data that are hidden, and basically shipping out those data, gaining insights onto those data and making business value-driven decisions. That falls under observability. And just to make it on a conceptual level and describe it in a table format, monitoring is basically having a pager or having a tool that just to denote like, is my system working? And whereas observability is like, what is my system doing? What sort of a payload that is deployed, and what is the end goal of running this system onto any cloud. The second is basically monitoring when something goes off in your pager, or let's say when you have a dashboard where you can see where you see like red dots popping up everywhere. That's called monitoring, because that's basically tells you when something is wrong. Whereas observability, apart from that also you get, let's say, insights, you get notifications, you get much more visibility onto the systems, and that's what observability is. The third one is my favorite, because I don't want to get up late at night where my pager get pinged up, turning on the laptops, going on through the VPN connections, because monitoring is mostly about reactive in nature. You react when your system breaks, when there is a hack into your system, when somebody has done some stupid mistake. Again, not stupid mistake, they have made some mistakes of breaking down your or injecting some bug. Whereas observability is something like it's proactive in nature. So whenever something fails, you basically adopt self-healing capabilities. You ensure that you have a full auditability onto that, like what sort of a mistake and why it has happened, to basically ensure that those doesn't happen into the future. Now, monitoring is basically, as shown on the previous slide, is just to enable like a quick response. So AWS has its own business plan. Partners of AWS, that like for what I am working, has their own customized plans. So basically, all falls under the monitoring aspect of seeing the system, where we determine like what sort of a response that will go into. But observability doesn't basically are only limited to those partners, those plans. It basically propagates or spreads across all the developers who are building those payloads, and every one of us who are basically responsible for building the system for anybody, for partners, for customers, for any product. We are responsible for observability. So basically that's why I want to highlight on this, emphasize on this point, that observability is not limited to a particular particular team, particular skill set, or particular practice. It's just something that we need to adopt while we are all builders in this cloud ecosystem. Now moving on to this, my second topic is telemetry. So we have gone through what telemetry is. So there are three signals that are responsible for shipping out those data. And now my next topic is what is OpenTelemetry and why this is like so much relevant in the current world. So back in 2019, we had like 2 projects, so Open Census and Open Tracing. And if I go back, I have seen, especially in the Kubernetes workloads, Open Tracing was used. If I go back much more further, we used something called Zool and other into the payloads as well. But then 2019, all of this community leads of Open Tracing and Open Census came together and said that we are co-committed to this observability cause. So why not come in synergy and work together? And that's why OpenTelemetry was born. And their first incubated stable release was in 2021. And that's where at least I saw the spike in traffic, where all the developers started adopting, coming together into the community Slack. So CNCF has started gathering the metrics of how much PR is going inside this open source OpenTelemetry project. And even today, or I would say not today, maybe 3 months ago, I just saw the statistics of the CNCF, and it showed like after the Kubernetes open source project, OpenTelemetry is the second one in line. So it's very much ongoing in the industry. It's still being modified. Many new SaaS platforms like Datadog, New Relic are coming into or boarding the train to adopt those. Now, let's say we have understood this, but okay, OpenTelemetry is coming into this. But if I deep dive into this, so what are the advantages? The first advantage is, as you can see in the screen, it's like a single way of capturing data. I know I have worked with customers who had Datadog agent as an ECS sidecar into their workloads. So 1,000 workloads, 1,000 sidecars. And there was a single team dedicated just to modify the dashboard containing or reducing the duplicate data coming or duplicate telemetric data. So OpenTelemetry removed all those overhead. So they said like you don't have to adopt any Datadog plugin. You just have to. We will come up with a single framework, and I'll showcase you I have a demo after 2 or 3 slides. So please hold on to your patience. But I have to showcase this one because I think this is important when we see it on a much more visual way. So OpenTelemetry did away with all the customizations, all the tailoring of all the manual overhead of how to basically cater to the plugins of each tools, be it Datadog, be it New Relic. By the way, when I mention Datadog, it's not like I'm against Datadog. It's just a tool I have been using so much. But I know all the tools has a similar feature. All both of them, every tool has the same flavor. Just the top layer is different. So if there is any Datadog people, don't come and bash me. And yeah, so the second point is the single way of capturing data. So you basically end up having a configuration file that you can see on the left of my screen, and that configuration file gives you the flexibility of maintaining a centralized space where you can control or where you can mention all the customization that you need to do. I'll show you how we have done that in the real world. But for example, let's say you can see the Prometheus endpoint. So let's say going ahead, we need to use something called New Relic, or let's say there is a new tool that is coming up. So previously what we had to do is like we had to go through all the architecture, all the payloads that was deployed and start customizing them, start re-architecting them, start making sure that they have those configurations so that they start shipping out data. But in this format, in OpenTelemetry, you just have to add one single line here. That's it. So basically, then what will happen, provided that new platform has OpenTelemetry framework already adopted, they will start shipping they will start flowing the data onto that system. And these are some of the terminologies, some of the jargons, but the main ones that I have tried to highlight here are processors, exporters, and receivers. And those are the same things that you will see here as well. So basically, receivers are the monitoring backend that you will see. So here, for example, we have X-ray for tracing that I'll again show on the console how we have done that. Then we have processors. Processors are nothing but filtering out your data, like what sort of metrics that will flow out. By default, OpenTelemetry has, I am not sure, but around 100 to 150 out of the box metrics data that are already flowing onto you. But if you basically let everything pass through, it will pile up on your cost. And the cost is not so less, because there is also a slide mentioning about what would be the cost after you cross your free tier limit. But yes, if you want to filter out and if you want to just ship out and visualize relevant metrics, you can do it through processors. And then the exporters is something, and that is a centralized configuration-based solution. And that is also where I'll again show a demo on that how we have hosted the exporter vertical. And this exporter is nothing but they are responsible for shipping out all those processed data from the payload to the monitoring backend. So that can be X-ray, that can be anything. And apart from that also, as I mentioned, I have been using this terminology for quite long, and I really love it. And I'll, of course, my end goal after the end of this demo is you will also appreciate why I really love this. So this comes with a tracing support. So basically, when the application or when the request goes through multiple systems, sometimes, or I would say when I go back previous pre-OpenTelemetry phase, this request propagating through multiple systems were sometimes lost, or it was a little bit difficult to get a visualization of that. But OpenTelemetry came with a much more conventional and open standard tracing support. For example, they have this HTTP ones, they have a database ones, and even they can actually call out what sort of a missing feature that you have. So if you have, for example, a wrong database query, or if you are querying against a schema that is not existent, so they will even fish out that and showcase to you as well. And on the right side, you can see basically they can support Kubernetes once, even though I have not used Kubernetes, but I know I have been using ECS, and they are easily adopted onto those Docker-based container services as well. Moving on to my next topic. If you remember 2 slides ago, there was a huge component of what sort of exporters and what sort of filters and what sort of receivers was there. So this slide basically talks about on a much more layman term, and how basically we need to re-architect our solution. So basically what we need to do is we need to instrument our code. Either we use Python or either we use Node or Java. So basically, if we use Java, we need to instantiate the OpenTelemetry plugin library. Or if we are using something like in Python, they have the similar one, and as well as in Java. So basically, we re-architect. We make sure that we create a library, or we instantiate the OpenTelemetry at the end. And then we start on adding whatever metadata that we require, or whatever custom metrics that we want to ship to AWS monitoring backend. And then we have a collector agent. And normally what we have done in our big clusters of, let's say, big companies where we have let's say 3 or 4 clusters which host around 15 to 20 services, around 100 to 200 tasks. So we normally try to centralize the collector agent. We make it reusable and scalable ones, and make them discoverable within internally using some service discovery. Again, I'll show it to you at the demo as well. How do we do that? And then the last is the monitoring backend, and this is the easiest part, and this is nothing but what a SaaS third-party system is. So this can be Datadog, this can be AWS, this can be New Relic, this can be Prometheus, this can be Grafana or anything, as long as it has the OpenTelemetry framework supported. All right, now the interesting part. So I'll just do a shift to my visual code, and if you see my visual code, so we have this. I have a Java application, and it's a Spring Boot application, basically running into an ECS container. So what it has, as I mentioned, so we instantiate the OpenTelemetry jar, provided that this jar is inside the library, and you can do it with Gradle, with Maven or whatever. And then after instantiating, we basically create a control in the controller. We start a tracer, And then inside the tracer, this tracer gets propagated across all the methods. So for example, we have a health check. We mentioned, we put this here. So we have an endpoint called index. We push it here, and that's it. So there is no other CloudWatch libraries, CloudWatch SDKs, and nothing. And now for the interest of the time, I just hosted the whole architecture in AWS so that I don't have to run through the infrastructure as a code. But let me see if this is visible, or where is the mouse? I think the mouse is here. So I have basically executed the endpoint of it. So this is my endpoint, and just to rename, just to make it like I have just executed it, and there is an endpoint. And when you execute it and when you go to AWS, you can see in the dashboard agent that this matrix has come up. So this custom matrix has started flowing inside this. So there is no CloudWatch adoption that is done. There is no CloudWatch custom matrix. So just adopting the OpenTelemetry, we have started injecting this. Now the interesting part comes here, that I have shown this, but where is my configuration agent? How does this payload knows that this needs to be done here? So here, so basically what we have done is we have kept a centralized secrets manager, and inside that we have mentioned like what sort of a tracing, where all this tracing data will go through, how the processors are, and if for example if we have a Prometheus, it goes to the Prometheus. If we have a Datadog, it will go to the Datadog, and all those things. And this parameter or this configuration is injected into all the ECS services that we host. So basically what it becomes, our application gets decoupled from any telemetric tools. We have an open source framework that is adopted. We have a centrally hosted configuration agent. So whenever, let's say, something gets changed, for example, we add another one, so we just update this version and respawn the containers. That's it. It will have the same feature. Any questions till now? Perfect. So then let's go back to the next point. So now coming to this is what I showed was for a single Docker container hosted into a cluster into one account. But what happens when we have multiple accounts, when we have multiple clusters, and when we have let's say umpteen number of services? So what we normally do is, one of the ways adding those collector. So AWS has its own collector agent called It's also like for example, getting improved, getting upgraded every time. For example, my application is right now using the version 18, but I actually saw that it went up to like 20 or 21. But yes, AWS has its own out-of-the-box sidecar that you can push. But again, like this actually limits you to the problem that I mentioned, so that you would, once it's a container-based one, so the more number of services that you basically go up to, it will increase the complexity of filtering out or creating a proper visualization of those data. So the next one that we have adopted is basically it's scalable one. It's a centrally managed one, and it can be used across multiple accounts. And what we have done here is basically we have hosted the hotel service. I'll of course go back to the console and show it to you. And we have OpenTelemetry service, and it basically what it does is like it doesn't have any payload. It doesn't have anything running into it. It just hosts the config parameters that I have shown, and then it has registered himself or herself into the cloud map, so that whenever other services get spun up, they are able to resolve this OpenTelemetry service by reading the cloud map. And cloud map is nothing but a service discovery, so that internally you don't have to maintain the private IP of this service. So what it does is like it can scale up, it can restart anytime, and private IP gets changed. But when we have that with cloud map, you don't mention or you don't make note of the private IP. So this by default gets attached to this cloud map, and you have a logical name that basically is injected inside all the containers. And finally, what these containers do, so these containers again become agnostic of all the telemetric framework. It can be open, it can be anything, and they just adopt the OpenTelemetry one, creates pane, and then filter out those datas, and then they start sending those metrics to this OpenTelemetry centralized config agent. And how we do that? How do we ensure that these ones are properly sending data to this point? And that is what I'm going to show you in this next demo. So again, for the interest of the time, I have basically ran everything beforehand. But this is the cloud map. And what you can see here is like we have a namespace, and then we have an instance that is running here. And this doesn't contain any private IP. So it just registers himself, and then it just keeps a track of it. And onto all the ECS services that we have, for example, let's say we have this custom agent that we have shown. So what we do, we basically create this exporter endpoint, and we call this via the local name service. And here what it does is like it starts shipping those datas, and then these are some of the naming conventions or the metadatas to ensure that once it starts flowing into any of the dashboard, we are able to properly identify those. And this approach is done for all of them. So going back to my presentation, what we normally do, we basically do the same thing for all the things. So we basically add those naming conventions for all of them, and then we end up sending those metrics. And if you go and if you basically visualize the dashboard, so we have around five services of the similar features, and what those features do, we'll see it in the tracing one. But normally what it does is like it starts shipping out the numeric dashboards for everybody. And the best part is like it's so much singular way of doing it that you don't have to adopt different approach. So either you can use the same approach, you can push it to a library, and then you can use the same library in multiple services, and they will have the similar sort of a way to ship out those logs, ship out those metrics. Perfect. So we have covered the metrics. Logs is one of the most. I mean, the question comes here like, okay, why it's still in an incubating phase, or why it's still like so much on demand of PR, like PRs are being put in, because logs is something that is missing. So the third signal, logs is missing on the OpenTelemetry part. And I know hopefully by this year or by end of this year, they will have this logs as well as part of the open source OpenTelemetry framework as well. So this is how basically in a much more bigger landscape, having multiple accounts, multiple clusters, we have metrics being shipped out. Now for the final part of my demo is tracing. So as I mentioned, tracing is really important, and I feel this is quite important while we host microservices. And I'm going to showcase a demo with AWS X-Ray. But apart from AWS X-Ray, you can use some other tools as well. Like Datadog has something called ADM, and other tools also has. But yes, coming to this demo, we'll use something called AWS X-Ray. It's again a tracing service. And what I can see, what I can actually realize, like they have drastically improved AWS X-Ray in the last couple of years. Because 2018, when I was using AWS X-Ray, it was just a tool without proper documentations and without proper way of explaining like how does it pass through, or what sort of insights that we get. But now fast forward to 2023, when I started using this X-Ray as a tracing tool, I am really impressed. And I'm gonna share with you as well after how useful it is. But normally, how do we do that? So again, it's a similar journey that we need to make. We have to instrument our code with the AWS SDK. we have to add some processors and aggregator rules, like sampling rules and some things. And then the third is just native to AWS, basically because AWS X-Ray is an AWS service. So we need to ensure like there are proper roles and permissions to the ECS instance, ECS task role that is attached when we spin up the ECS service. And how do we do that in the code? So what we do is like we inject those sampling rules, and then we can do. This is a Java code, but this is pretty much equivalent, or this is pretty much prevalent for all other Python and everything as well. So what you do is like you ensure that you have a particular static part of a code which runs when the application spins up. And what it does is it creates the AWS X-Ray library. It injects the rule. It basically tells you like what sort of a API request that it will track. Does it need to send all those tracked requests in a batch, or it will be a real time? But this is how you normally do it in Java, and similarly in other code as well. So the main reason of doing this is like this is not for every request. So this is just done once when the application gets spun up. And in the end, you will get a traceability matrix like this. So what you can see, like we have a Fargate service. So what I have done is like basically there is an S3 bucket. It puts a byte object into it and adds the key to the S3 DynamoDB table. But what it normally does is like you can see it does it tracks all sort of a requests that it makes, not only the ones that we are seeing like the endpoint one. It basically goes down to the IAM roles, metadata of the container to check if the IAM roles contains proper permissions. It goes to the DynamoDB table. It basically, so all of them contains with a time to return. And then when you look onto the right side of my screen, you see that there are metadatas. There are like start time, end time. So whole sort of a matrix, whole sort of a data that come out of this. And that is just by adopting a single library. Now coming to my demo, or coming to the thing that I'll show, and that's the last part I'm going to show it to you. So basically there is a API, and that is hosted onto a ECS container. And as you remember from the previous slide, so it has a DynamoDB table and S3 injection. But apart from that, also just for this AWS Community Day, I did some more additional flavors. So I did chaining of requests. So basically what it does is like there will be one API on the top that will call this API, and then there is another API that will go to a third-party remote website. And then there is another API that basically does some other stuff, like for example, querying a Postgres SQL. So this is what I'm going to showcase to you. So the first one will call a third-party web server hosted somewhere using some Cloud Spring Fine client. And then we have the second web server, so the second request, which basically puts some object into S3 and then updates the DynamoDB table. And the last one is showcasing that it sends a select query request. And to ensure that my code or my demo fails, I have basically deleted the schema. So to ensure that I am able to view the traceability. So what I will do, I have already basically spun up the whole entire architecture. So what I will do, I'll just execute a request. And I'll just copy this one. I'm not sure if it's the proper one, but yeah, we can of course try it out. So what you do is like you come to this console. You can query on sort of a nodes, different type of nodes. So for example, I can query if it has hit the Fargate one or if it has hit the other ones as well. But what I will do is that I'll just query on top of this. I'll just let me double check once if it's the Fargate proper one. So I'll go to the Fargate one, 49364. Okay, I hope this is the proper one. Yes. Okay. So I have made a request, and you can do any multiple number of requests, but normally what it will do the same thing. So it generates one trace for us because we have requested it once. And internally, so if I go here, you can see basically like a whole chaining of requests and all the metadata that come up with it. And as I mentioned, that I deliberately deleted the schema it is reading through. So you can even have a highlight of, okay, this one is failing. And if you go down, you have like a sub-segments of everything. And these are all chained. So you can see like what is the parent ID and what is the sub-segment ID on top of it. So you have a proper traceability of everything. And apart from that also, you can basically, I'm not sure why this is not going, but let me see, yeah. So you can basically find out a fault of this as well. So if I click on this, and if I go to the exception, so there is this tab called exception. And it basically tells you the message as well, like why there was some, it was failing. Because the query that because the schema I have mentioned that it's deleted, it's going to a different one. And if I run the schema and if I run the same request again, this will become green. So this is a really good advantage of using traceability and seeing multiple systems when moving around different systems. This can really be helpful. But again, one of the things that I would like to highlight here, and I have seen people asking very much questions about this. No, you cannot track signals from other third-party APIs. So this is just internally for all the systems that we hold. But let's say we have a third-party system deployed on Google or Azure. So then we need to ensure that that system has those traceability metrics adopted into it. Or let's say if we use some SaaS tool that we can, for example, if we integrate Jira or something like that, no, we can't track of that. This is only prevalent for systems that are deployed, that are present within the AWS realm. Now coming to the serverless ones, is it possible for, I wanted to ensure that, yes, this is possible for serverless as well. So it's not only the REST-based payloads or the ECS containers that we can find out the tracing. We can do that in the AWS Lambdas as well, and it's much, much more easier. So it's just a ClickOps thing that you need to do. You don't need to run up anything. So there is one single, if you're using infrastructure as a code like Terraform or CDK, it's just one plugin that you need to do, enable traceability. If you do it through ClickOps, you have just one button like toggle if you want to add traceability onto it. And that's something called enable configuration. And then the third part is again the role thingy that I mentioned on the last part as well. So it's the same thing. You need to ensure like you have proper roles and permissions to put into your AWS roles that is responsible for running this Lambda function. But yes, if you see on the screen, it's the same thing. So it gives you an automatic traceability if it's a Lambda to Lambda function. Whereas I personally don't believe this is a good approach. You shouldn't use or you shouldn't invoke Lambda inside another Lambda if you really have some opinionated test case. The best deal is to go through some event bridge or make it as much decoupled as you can. But yes, I think last month or the month before, they have even added the SQS capability inside it as well. So if you, let's say, if you want to decouple this, if you want to go to a much more best practices like have a SQS queue on top of it, you can even do that. And you can even add that traceability here as well. Moving to the final OpenTelemetry metrics, this is something that I just tried to showcase on the AWS world, how you can do it. Previously, there was Datadog, what I showcased here, but yes, you can achieve the same thing here as well. I'm not sure how many customers are using CloudWatch right now to do the observability, but yes, it can be done using AWS CloudWatch as well. We don't need to be dependent on some third-party platform. Of course, there is, no, I don't think it's an issue anymore because AWS has come up with multi-account one, but previously there was an issue that you can only visit it account-wise per account. But now AWS has given that you can aggregate from multiple accounts as well. Now coming to the main important pocket burning or pocket pinching thing, how much does it cost? So it's really good to adopt all these things. It's really good to spin up. It's really good to see all those things. But does it really ends up a lot? And the question is, it depends. Again, how much do you actually plan to customize it? So if you have a huge amount of customization, if you basically have a whole lot of requests, big systems, and you want to monitor everything, you don't want to leave out anything, it will cost around 245 to 250 after you go up the free tier. And there is a free tier, I think it's about 1 million requests or 100,000 requests that is free per month. But apart from that, above, on top of above, and the assumption that I have given is like a huge one. So that is also not something that we normally use. We don't monitor every request. We don't have so many requests running. And then the last part, the CloudWatch. And then this is also something relevant because customers doesn't use CloudWatch every time. They go for up enterprise third-party tools or SaaS platforms. But yes, provided with a 20 custom metrics from 10 instance and having a 1 GB of log volume. And 1 GB of log volume is like you are pushing verbose log. So you are pushing everything, not only hello world or hello Aritra. Everything that is going from the payload, you are pushing it here. Then you would end up having something like $80 per month. And again, this is after the free tier. Perfect. All right. So just 20 more slides remaining. Just kidding. I'm done from my part, and really thankful. Thank you to thank you everybody to listening to this, and it's my privilege to present in front of this erudite crowd, not cloud. Of course, the cloud is erudite, but the erudite crowd. And just reach out to me if you have any questions. Thank you, sir.